Welcome back to our series on solving equations with fractions. Here are thinking and application questions based on the concept. We'll show you different strategies and methods of solving such questions. I'm Anil Kumar. Welcome to our website, Global Math Institute. To learn more, you can send an email on the address given. In this video, we'll discuss thinking and application questions based on solving equations with fractions. It is in continuation of our worksheet with 25 questions. We have given you these questions in the worksheets. I hope you are able to solve them. However, here are my suggestions. In case you want to learn from me directly, send an email. We can work out a schedule. Let me remind you of the questions which we did in the worksheet earlier. So basically, we had these 12 questions which could be solved by the method of cross multiplication. So these questions which you see, we categorize them as type 1 and type 2, and they can be solved using cross multiplication, correct? And then we had another set of questions where common denominator was the main strategy to solve the equations. So multiply each term with the lowest common multiple, and then you can solve these questions. As you can notice, in question number 11 and 12, we have two very special questions. And these are where we have x squares and not the linear terms. How do we solve these questions? Along with this, equation 11 and 12, which involves x squared, we have now added two other challenge questions. They will involve thinking and applying strategies which are slightly different. And with these strategies, you will be mastering the skills of solving equations with fractions. I hope this is clear. Let us enjoy the journey of learning. So we had those solutions earlier. Now let us look into the special cases. Special case 1 is where we have x squared involved. I had given you a hint earlier. If you have equation of this kind, which is like a proportion, you can do a substitution. So we'll learn the method of substitution now. We have x squared, so we say let x squared equals to some other number as p. So that is our let statement. So we are saying that let x squared equals to p. In that case, what happens to the equation? The equation becomes p plus 1 over p minus 1 equal to 5 over 4. Does it make sense to you? All of a sudden, with a simple substitution, we have converted this equation in previous types of equations which are like proportions. So we can now cross multiply and solve, right? So now that converts to what? That converts to proportions, right? And now what do we do? Now we solve by cross multiplication. So let's cross multiply. We get 4 times p plus 1 equals to 5 times p minus 1. Open the bracket. 4p plus 4 equals to 5p minus 5. Bring the variables together. So we have 4 plus 5 equals to 5p minus 4p. And that gives you the answer for p equals to 9. So we have the value of p. Now what to do? We need to really find. We have the value of p. So we know p is equal to 9. But what do we need to find? We need to find x. Substitute back. We have x squared equals to 9. You get the idea. So that gives you that 9 is basically equal to x squared. That is the substitution which we did. And from here, you can find the value of x. Can you now write down the answer? So, we have x as equal to square root of 9. Some of you will only write one answer, which is 3. Even after doing all this, that will be incorrect. Can you tell me why? Mainly because when you square root, you have to do both plus and minus, and therefore the answer should have been x equals to plus and minus 3. So for this equation, you see how we have got the solution, correct? That is how you have to do it. I hope the strategy is clear. Now, I would like you to pause and solve. Question 12. That will help you to gain confidence, correct? Here is my solution. We are substituting x squared as p. So we get what? We get 2p minus 5 over 5p plus 2 equals to 3 over 22. Now we can cross multiply. The numbers are slightly bigger this time, but the strategy is exactly same as you can see. Now these are the type of questions which you expect in the test papers. Does it make sense to you? So now you have to multiply 22 with both the terms in the bracket. 5 times 2 being 10, 5 times 2 10 and 1 11 equals to 15p plus 6. Bring the variables together. 44p minus 15p. I prefer to keep the variable term with a positive coefficient. You get the idea. It is easier to work like this. Now, take away from 44, 15. What do you get? So take away from 4, that is giving you 9, and then from 3, 29. And we have here 116p. So that is what you get. Now, you can divide 116 by 29. What do you get? So 116 divided by 29 is equal to 4. That is the value of p. And as you know, p is x squared. So we can write x squared equals to 4. And now you know what is x. It is square root with positive and negative sign. So it is plus and minus 2. Is that clear to you? So that is the way to solve these questions. Correct? So I hope you have understood this strategy where a substitution helps you to simplify the question, write it in a linear form, and then you know how to solve linear equations. Right. Now let's look into the word problems. The main idea here is to also model the real life situations and then solve the related question. So this involves modeling the real life situation, right? So here we could use this strategy to model the real life situation. The question here is, difference between two positive integers is 50. The ratio of these integers is 1 to 3. Find the integers. Now this question can be solved in many different ways. However, we will understand our method of solving equations with fractions first. So let me call this as our method 1. Now in this method, we say difference between two positive integers is 50. Now how do you define these two positive integers? So let us say if x is one integer, then what should be the next integer? It could be x plus 50, for example. Do you see that? So if I have x as one integer, the other could be x plus 50. So that gives you a difference of two positive integers as 50. You get the idea. Now some of you will do in two variables. You say, well, x plus y equals to 50, right? So in that case, you will say y is equal to 50 minus x. And then you have two integers. which are 50 and 50 minus x. So that becomes an alternate way of defining your integers. Either way, you could do it. However, what I prefer is the first method as it involves additions. Now, it is always simpler to use addition rather than subtraction. Nothing wrong with any of these strategies, both are kind of same. You get the idea. You could use any one of them and then try it out. Okay, so let's continue with our solution. We have the two integers whose sum is 50. That means the integers could be what? X and x plus 50. We could define this with an let statement. Is that clear to you? Let x be one integer, the other will be x plus 50. Right. Now, since difference between two integers is 50, we have defined the two integers. The ratio of these two is 1 to 3. It means that x over x plus 50 is equal to 1 to 3. 1 is to 3. Now, since x plus 50, we're talking about positive numbers, is greater, it is good idea to put the ratio as 1 is to 3 in the right perspective. You see the idea, right? So this is how you will get it. Now the strategy is to cross multiply. So we have 3x equals to x plus 50, and you can bring the x together, and then you get what? 50. 3x minus x is 2x equals to 50, and that gives you the value of x as 50 divided by 2, and you know that x is 25. Does it make sense to you? Straightforward solution to this very important question, right? Now, you could have this as a word problem. It is kind of distributing the money, which can be done between two, right? So we could give an application question here, which could be what? Look here, application. Sum of $50 is distributed in the ratio 1 is to 3. How much will each get? You get the idea. So, a straightforward question. It is a real life application which could be done like this, right? So, let's now look into method 2. Method 2 is very, very simple. Now, it says the ratio of two integers is 1 is to 3. So, we'll focus more on the second statement, which is ratio of integers is 1 is to 3. So that means if one integer is x, then the other integer is 3x. You get the idea. So that really implies the statement that the ratio of these integers is 1 is to 3. Does it make sense to you? Have a good look at it. This will change the whole perspective of solving the equation. If you could look the second part of the equation first and then get to the solution, you will straight away write ratio of these two integers 1 is to 3 means one integer is x, the other should be 3x. And now, looking into the first, difference between the two integers is 50, we can write our equation, that is 3x minus x equals to 50, and that gives you the solution 2x equals to 50, or x is equals to 50 over 2, and that gives you x equals to 25. Do you see this part? I would like you to focus and understand, how do we solve word problems? How do we tackle them? That is the key idea of this particular video. Sometimes you may have to interchange the statements. The second statement could be a critical starting point for you. Get the idea? So I'll definitely look into this statement first and use the method shown here, right? Such a simple solution, it may not even involve equations involving fractions. Does it make sense to you? And how do I apply this in real life situations? Look here. We have hundreds of examples which relate distance, speed, and time. Distance, speed, and time. You know that. hundreds of applications involving distance, speed, and time. And distance is equal to speed into time. And if you want to find time, in that case, you have to divide the distance by speed. Now, you could write this equation either way. However, which is better? Working with distance. So if you work with distance, you land up with a straight linear equation, maybe quadratic, but without fractions. That is the key idea. So when you're looking into the application questions, the focus here, when you're looking into application questions, think critically, connect with your learnings, and then solve. Does it make sense to you? I hope it does. Now let's move on and take some challenging questions, right? Now, here, the question will definitely involve fractions. The question is, a fraction is such that if the numerator is multiplied by 3 and the denominator is reduced by 3, we get 18 over 11. But if the numerator is increased by 8 and the denominator is doubled, we get 2 over 5. Find the fraction. You get the idea. Now, we have no option but to work with fractions. So, we'll say let the fraction be a over b, right? Let the fraction be a over b, right? Now, if the fraction is such that the numerator is multiplied by 3, so that means numerator is now 3a, and denominator is reduced by 3, means b was a denominator reduced by 3. Does it make sense? When the numerator is multiplied by 3 and the denominator is reduced by 3, so we got our equation. It gives you 18 over 11. Clear? So this is 18 over 11. You get one of the equations relating A and B. Is this step clear to you? Now, let's look into the second statement, which says, but if the numerator is increased by 8, so let us increase the numerator by 8. And the denominator is doubled. Denominator is b, it is doubled. Then we get 2 over 5. Then we get 2 over 5. So we have two different equations. You get the idea. And that is why this is a challenge question. So, but if the numerator is increased by 8, I increase it by 8, and the denominator is doubled, I doubled, we get 2 over 5. We get 2 over 5. Does it make sense? So, first thing first, get your equations right. And then we can look into the solution. So, let us cross multiply. So, we get 3a times 11, which is 33. And here we have 18 times b minus 3. Similarly, I will do here 5 times a plus 8 equals to 2 times 2b. Simplify this. 33a equals to 18b minus 3 times 8, 24, and then 2, 3 times 3 plus 2 is 5, 54. So we have related A with B. On this side, we have 5A plus 8 times 5 is 40 equals to 4B. So we do have a relation between A and B. The question is still very challenging. You can now use different strategies to solve this particular question. Correct? So the idea here is that the 4B is 9A plus 40. And in this case, we get 18B is equal to something, right? So what we could do to solve this further, we need to simplify it in terms of A and B. One of the variables can be reduced. And so you can now substitute the value of A in B or the value of B in A and then further solve. You get the idea. So I will actually leave this statement right here for now, since the students who are doing this particular exercise have yet to learn linear system of equations. So in linear system of equations, we'll teach you two different methods. One method is called the method of substitution, and the other method is by elimination. Using these methods, we can solve this particular question. However, the solution for this, for those who are really interested, I have a video solution, so we'll provide a link for complete solution. Is that okay? I hope you find this video interesting and useful. You can learn from me by sending an email on the address given. Get connected and enjoy the journey of success with Anil Kumar. Thank you.